Our laboratory had a significant need for additional space to be added. We knew we needed something on the order of 120,000 square feet.
In the case of this building, it was critical to get in as soon as we could.
Time was a big issue for us. If we had to build this thing in a year, it had to move quickly.
And they were looking for a different delivery method.
Over that probably about a year time that we were looking at what we needed to do or what we could do, things kept changing.
We needed a building strategy that both our client and the bank could easily understand and support.
The developer, Mike Coyle, went to Scott and we started working up some ideas. Scott came in and got involved, and one of his thoughts was precast.
This structure is suited for total precast because from the onset it was designed as total precast.
It's basically our team's knowledge of the precast industry and our knowledge of total precast structures that allowed us to bring this thing in so economical and have the erection schedule that we did.
Because we were combining all the things that most architects and engineers don't know. We had the inside scoop, basically.
The exterior of the building is complete when these precast panels go up. So there's no scaffolding of the building, there's no multiple trades working outside and climbing over top of each other. The second reason is the speed of erection. We wanted to get the building closed in and under some sort of temperature control before winter conditions set in Pennsylvania.
We bid this out to all the site contractors, and from my past experience I knew that that Amron Construction would do a very good job, and their job superintendent, Carl Beckwith, is a fantastic superintendent for a project and really knows how to keep the project going.
From stripping topsoil, we had our pad ready within 3 weeks. We had another roughly month and a half in footers, and then the site, the erectors were in. The building next to us there, if I remember correctly, I believe they started late last fall. We come in early spring, and we'll still be months ahead of them by the time we leave this site.
The building was different in the fact that we don't see a lot of total precast buildings. We see a lot of precast incorporated in buildings, but you never see an architectural precast facade like this with a bunch of structural elements a whole lot.
We basically have 4 typical molds on this entire building that allows the precaster in each mold to make a piece every day. By getting that efficiency, we were allowed to make the building very ornate. We took the ability of tremendous amounts of repetition, but by using different techniques, the building does not look as repetitious as it really is.
The architects want the building to be pleasing on the outside, and before now it was difficult to accomplish that with a precast structure. With the advances in terms of liners and the forms and the ability to put face brick and integrate architectural details, I think if they had the experience and learned the ins and outs, they'd become proponents as quickly as I have.
But to see the net look in this type of a building is very impressive because of what they were able to produce in terms of making it look like there's limestone at the bottom, all the brick that went into it. I mean, it is real brick, just thinner. For this project here, they actually took stones to make the molds. They laid them in and poured the rubber and made the molds straight from real stones that you see out there.
Some sort of sketch appeared and drawings, and before you knew it, and it was like, yeah, we could definitely do something like this. In our plant, the stripping crew comes in first. They're charged with removing what was cast the day before. Then they come in and they get their production orders. And then molds start getting filled. Now, after it's stripped, there's another crew that goes out and they're charged with cleaning. Obviously, we check our quality before the form is cast, and you have to check it every day. You know, we like to give our product with a plywood core in it. The tolerances are much better. The life of the form liner tends to be longer. So, you know, you're building something in itself, and then you're also putting an art form liner with it as well.
You know, when you go out and buy your Legos, every Lego is the same. They all fit together. It's a manufactured, controlled product. If they were making each Lego individually and different, they wouldn't fit together. Nobody would want them. Well, it's the same thing with this precast.
We are a custom architectural firm certified by PCI, we have a better control of our strengths and the curing of the concrete by having everything on site and in the plants. We pull from dyes that come in primary colors, and we can make any color in the spectrum. And because concrete starts out in a plastic state, we can create any shape of panel you want. It's a lot like making cookies, that you make a form, and whatever you want that to be, the concrete will form to that, and then once it cures and is hard, you strip it out and you got the shape that you build it for. The only thing that you're limited in precast is your imagination.
Their goal is that they want to be able to pull a piece of precast out of the plant, out of that form, every single day, and put another set of rebar in and pour another piece the next day. So they're using higher quality cements. And what basically we have here is 4 times the strength, 4 times the resistance to penetration of water, which is what typically breaks down mortar. We don't have the field conditions, we have plant conditions. Basically, you should never have to go back and repoint a mortar joint on a total precast building.
For this particular job, we used a 275-ton crawler, Manitowoc 999, and that was required for some of the heavy lifting that we had to have different radius pieces we had, or the different weight pieces at different radiuses that we had. The ability of our operators to make it look so smooth, they just know where to pick the piece off and how to rotate it. We have hook-on men that their sole responsibility for that particular job is to make sure the pieces are hooked up right, all the rigging is correct, they have the right length chokers, the right length rigging, and then it's the responsibility after the hook-on guys to make sure the pieces gets to the spot properly and is set down with the right amount of shim in plumb, both horizontal and in a vertical direction. And then it's responsibility of the foreman in the final position to make sure it's right where it needs to be.
We set the piece. We get it close to plumb with a bracing. We look outside, make sure all the brick false joints are right, and we just shoot it, try to match it within 16, 30 seconds, or whatever we can do to make it perfect. And that's about it, welded in place.
Those guys just worked as a team, and everything they put in, they were looking at making sure things were plumb, level, straight. The building fit together fabulously.
You go by one day and you come back a couple days later, and it's amazing how fast it goes up.
I think their deadline is July 19th. I'm shooting for June 12th so I can be home for the summer.
For phase 4 will be good doing that.
Yeah.
But then when we move to phase 5, then...
Well, the way I'm looking at for phase 5 is at that time where we're going to be putting the trailers in. For the precast erector, we had 5 phases of construction. Those phases were coordinated with the location of the crane. The crane was set up initially for phase 1 and then relocated 5 times during the erection of the structure. All of this was pre-coordinated prior to the start of work, so that all trades knew what areas would be accessible or inaccessible to other trades during this construction.
Once we got done with phase 1, we were able to turn that over to the construction manager and let him begin his work.
Long before the building is completed, we have metal studs going up, we have rough-in electric going in, rough-in HVAC, and all those items that typically had to wait until the framers were out of the way. It makes it much quicker than conventional construction. It allows subcontractors to get in and do their work and remain on schedule.
They grouted the roof decks and poured second floor, third floor decks, and the phase 3, phase 4, they hadn't even started on.
It flows literally like clockwork. You can watch a piece come off the truck. The guys that are rigging it are in the exact spots that they need to be. The guys on the building, they're in the exact spot, and it goes up. You could almost put it to music. It's that beautiful to watch.
This building is going to achieve LEED Gold certification, which is the second highest, second only to platinum. And the funny thing about it is we weren't even trying to achieve that. We were just trying to achieve a very high quality facility for our tenant.
A precast concrete building lends itself very well to LEED certification. This particular construction is a layer of insulation sandwiched between 2 layers of concrete. And it has a very high R value, which means it's a really well insulated building. The aggregate and the cement and The sand that goes into the concrete is all regionally extracted. And they use rebar that has a high level of recycled content. So the product itself is very environmentally friendly.
I can tell you that on this project, had we gone with a traditional steel frame structure, it would have been at least 15% to 20% more expensive for the facade. We would have had higher life cycle costs, and this structure would have taken 16 months to 18 months to construct and turn over to the tenant. We're going to turn this structure over in 9 to 10 months from when we first started construction.
We have so many great minds in the precast industry that can build the Sunshine Skyway Bridge, that can build buildings, the Transamerica building in San Francisco, that can do so many different precast projects that want to grow the industry, that I think precast has an infinite ability to continue to grow.
Certainly, I think in terms of the cost, we were surprised at how cost effective it was.
It's kind of a monumental building to me. It's the nicest thing on Science Park.
When you actually look at the exterior of the building, I kind of like it.
A LEED certified building is a healthier place to work.
I think we've also sort of answered the call, or constantly answering the call for new and different things.
Ceramic tile, brick, stone. We can put any kind of veneer in our panel that you can think of.
It's an unbelievable amount of work that happens in a short period of time because of the method of construction.
Faster we get done, the company makes money, they make money.
When an architect or an owner decide that they want to build a total precast building, I couldn't agree more. You're making a great decision. This is a specialty. Treat it as a specialty, and you should consult somebody that specializes in precast in the early phases of design.
I know this total precast system will continue to offer a much higher level of value to our clients, so I'm really excited about our future.